Hello everyone, in this lecture we are going to learn about the last protocol for the flow control, which is a selective repeat and ARQ protocol. So in stop and wait ARQ protocol, both of which had some drawbacks, and then go back and ARQ protocol, which too had some limitations. It requires a more bandwidth while retransmitting the data packets. So now to overcome this problem, we came to an alternative technique which is known as a selective repeat protocol. So in all this protocol, we are just sending data packets to the receiver. So in that time, it is somehow the time consuming, or it somehow requires a more bandwidth. Yes, so for that the new protocol is introduced, which is a selective repeat ARQ protocol. So what a selective repeat protocol does is that it allows the receiver to accept and buffer the data packets following or damaged or lost one, and then retransmit only those data packets which were lost or damaged in network channel during the transmission. So it is something like that. In our go back and ARQ protocol, we are transmitting the data packets from the lost packet. Yes, all the data packets from lost packets are retransmitted, but in this protocol only those data packets are transmitted which were lost. So let's understand it with the example. So consider you are sending the data packets indexing from P1 to P5. Yes, so there are 5 data packets. Now P1 and P2 are received successfully, and the acknowledgement is also given to the sender, but packet P3 got lost or damaged in the network channel. Yes, so as I said that there are total 5 data packets and 3 is lost. So as per the go back and ARQ protocol, all the data packets 3, 4 and 5 is again retransmitted. But as per the selective repeat protocol, the sender will send the packet 4 and 5 which the receiver will receive, and after that, yes, so 3 is lost, but after that the packet 4 and 5 is received by the receiver. So positive acknowledgement is given to the sender. Only 3 is lost. So the selective repeat protocol will only transmit packet P3 to the sender, P3 to the receiver. So here we are not transmitting multiple packets for one data lost. So this is how we can save our bandwidth, and this drawback of go back and ARQ protocol is resolved here. Now the retransmission request may be done in 2 parts, which is implicit retransmission request and explicit retransmission request. So in the implicit retransmission request, here it is the receiver's duty to acknowledge or give the positive feedback of a received data packet and negative feedback for those which were lost or damaged during transmission, and that too before the expiry of timeout. Yes, so here no one requesting for the acknowledgement. Sender is not requesting for the acknowledgement. Yes, a receiver by own transmit the acknowledgement to the sender of received data packet. So that types of retransmission is a implicit retransmission request, while in the explicit retransmission request, the receiver can request retransmission of just one packet. Suppose there are 5 data packets that is sent by the sender, but the third is lost. Yes, so receiver received 1 and 2 and 4 and 5. So at that time, if receiver requests for the packet 3, then that type of packet request is called the explicit transmission request. So either on both approach are used in the practice, so that both are valid. This protocol is almost like a go back and ARQ protocol, or we can say that It is a modified form of go back and ARQ. The part where it differs is that here buffer are used and both receiver and sender maintain a window size. The selective repeat protocol works better at time when the network link is mostly unreliable, because here in this case retransmission tends to happen more frequently. The selective retransmission of frame is much more efficient than retransmission all the frames. So selective repeat also requires a full duplex communication channel for consistently transferring the data packets and the feedback and acknowledgement. So suppose the channels are not reliable, so in that situation it may be possible that multiple data packets may be lost. So in that situation, if we are using a go back and ARQ protocol, then we need a large bandwidth, because if one data packet may be lost, so from that all the data packets are retransmitted. So in that type of situation, a selective repeat protocol is used. Selective repeat means only a selected packet may be only a selected packets are retransmitted. So that is why it is called the selective repeat ARQ protocol. The sender's window must be equal to the receiver's window, and window size should be less than or equal to the half of the sequence number in the selective repeat protocol. So this is to avoid the data packets being recognized incorrectly. So here the size of the receiver is not 1 but same as the sender or half of the sequence number. If the window size is greater than the sequence number space, and then if feedback or acknowledgement is lost, then the sender may send new data packets that the receiver believes are retransmission. So exact number of transmission cannot be recognized. The receiver then stores the correct packet until they can be delivered in order to the higher layers. So this is how the selective repeat protocols is work. Next, let's understand it with one example. Now in the diagram, the sender first send the frame 0, then send frame 1, then it send frame 3, which is a 1. Yes, the third frame is 1, and this is lost. So here the acknowledgement of 2 is received, but acknowledgement of 1 is not received. Then after this protocol is able to send multiple frames to the receiver. Here receiver doesn't receive the frame 3, so it does not send any acknowledgement to the sender. So now as we can see, frame 3 is lost during the transmission and was unable to reach to the receiver, but the next frame, which is frame 4, is transmitted and also accepted by the receiver, who then sends a negative acknowledgement, due to which the senders only transmitted frame 3 instead of retransmitting all the frames starting from 3. So in this scenario, only the frame 3 is lost, so only frame 3 is retransmitted, not all other frames are transmitted. Yes, so that is the benefit of this selective repeat protocol. Next is advantages. So fewer retransmission, that is the main advantages, and the disadvantages are more complexity as sender and receiver. Each frame must be acknowledged individually, and receiver may receive frames out of sequence. So these are some disadvantages that we need to handle while using the selective repeat ARQ protocol. Thank you so much for listening. Have a great day.